Okay, this morning we're going to do a flatness analysis on this particular wall. This wall is roughly an 11 by 9 foot wall section. And the first thing we're going to do is we're going to move our construction plane to that wall surface. We're going to do that using this tool. I'm going to shoot an x-axis, x direction, and a y direction. And those 3 points, those 2 lines, define for us a new construction plane. And as you can see, our datum processing was completed successfully. So this surface is now our construction plane. In order to create the outline of this surface, I'm going to be shooting on the surfaces, the planes that intersect it. So I'm going to be along the ceiling, along the side wall, along the floor, and along this side wall. So let's do that. I'm going to go to my line tool. I'm shooting a line along the intersecting wall to get the right side of that wall. I'm selecting a line on the intersecting floor that runs into that wall. And I'm going to hit the side wall on the left. And then we're going to hit the ceiling to get the top surface. Now that we've got a perimeter here, we're going to trim that out using our Smart Trim Both. And it just kind of anticipates what we're trying to do. Click the mouse and you're good. So this is our wall. This is the surface. This is the actual, for example, the actual angles. It's not a bad wall. Pretty good, pretty well made. But what we want to do now is analyze the flatness of this. A lot of times people need to analyze and correct for the perfect flatness of a wall. So to do that, we're going to go to our points. I'm going to right click that and go down to Scan Points. Notice it says to select 3 points. And we're going to define basically a rectangle or square area that it's going to analyze. So I've set the scan to 24 inches. So our scan grid is going to be on 2-foot sections. And it tells me to select 3 points. It's going to define that grid area. You'll notice that the laser is pointing and aiming this all by itself. And 2-foot sections. Okay, our grid has been completed, as you can see here, and we're going to go to the analysis tool down here on the bottom. So this is plane analysis. I'm going to select it. The points that I want to have analyzed. Remember, we made these points as 3D points, so they're each sitting in space wherever they actually happen to be. So I've selected them all. You can see they've turned orange, and I don't have any of the wall pieces selected. I'm going to hit accept on that. And what it does is it analyzes it. The farthest out section of this wall is going to be a 0 in red. So here's our farthest out section of the wall is right here. And if we zoom in a little bit, you can see other parts of the wall are as much as 3/16, even 5/16 below, lower than that section of the wall. So all of these zeros are at the same level, but this is the one that perhaps it's some 4 or 5 decimals out is the farthest out one. And again, looking over here, you can see this isn't too bad a wall, but it does have some movement in it. So if I wanted to create a fascia on here that was perfectly level, I don't need any inserts or spacers here, or I need a common amount of space there. And then I need more spacer, and more spacer, and more spacer to flatten up this front surface if I wanted to make it perfectly vertical. So that's one way of analyzing just a wall and taking a look at where how much you'd have to shim it to put a fascia on that would be perfectly vertical.